All right, let's get going here. We're not going to wait too long on this one because this one has been a long time coming. This is the Unit 10 Linux Security Engineering course. I'm finally getting around to recording it. My name is Scott Champagne. I've been doing all of the courses up until this point, and this is the Professional Linux User Group's version of how we kind of secure Linux. So let's go start getting into it. Announcements. This is the 10th class meeting for this group. We met actually a couple weeks ago, and then we've been pushing it off, and we're getting ready to do our 11th meeting this weekend. Now, there's no actual official meeting for week 11. We're just doing it so that people can do their presentations and those kind of things. So there's that. And then a reminder, we've got a big virtual conference coming up on August 8th, 9th, and 10th. I'm going to have a bunch of speakers coming in from around the industry. So people that are trying to get into the industry and want to talk to people about it and see kind of what's going on. And I'm going to have some data analysts, some economists, just different people that do stuff around Linux and Linux adjacent type systems. We're going to have people all over. A lot of cloud engineers are coming to talk to you guys too. People that work specifically with AWS and Azure as well. So that's coming up. So what did we do last week? Well, a couple weeks ago now. We had two topics. One was on key management and how we deal with public and private key pairs to get into systems. And the other one dealt with TLS encryption and how the operation of TLS is affected and how it secures systems, right? So those were the main things that we did there. You had some notes, and then you had a lab on certificates and generating certificates and securing TLS. Actually, we secured our syslog with TLS, so that was good. And then we did keys where we destroyed keys and regenerated them from a private key, because you can generate as many public keys as you want from a private key. And we went through all that stuff, right? So that was what we were reviewing from last week. This week, we're going to be working on we're going to review everything for the first 10 weeks. We're going to look at Linux holistically, securing the system, and what those kind of things look like, all right? The two topics that you're going to talk about for this week, journal topics, and then also proof of skills. So what that looks like here in my little doc is capture all the terms and concepts that we talk about in this recording. Keep notes, right? I always want you guys to keep notes. And then how many new topics or concepts do you have to go read about? You know, the goal of this as we talk is not to have shown you everything about security and then you can put your pack down and go, I know all security. No, it's a process, and you're going to learn more and more as we kind of go, right? What was completely new to you that we talked about today? What's something that you heard before but needed to spend some more time with, right? And these are ways that we learn things. We start to read about new technologies that are emerging, and we're like, oh, I know what that is, and I don't know what that is, so I need to go spend some more time reading about that and looking at implementations and stuff like this. This is a sign of maturity in engineering, right? Like, I know that I don't know everything. I have to go read and figure out. But the implementations kind of boil down to a lot of the same things, so we're going to look at that. All right, and then the second part of the discussion is proof of skills for the course. If you were to do this course and just put, on your resume, some guy from some internet site and some Discord that we hang out in taught me some stuff and I know stuff, that wouldn't go over very well. People would be like, I don't fucking care. Same thing with my college students. If you put down that you're in a Management 800 course, who cares? The topics that we went over, though, and that's what we're going to review today, could you talk to each of them? If I said, hey, you mentioned on here that you understand PKI certificates and X509 certs, could you tell me a little bit about that? Something I would ask on a resume if I saw that on somebody's resume. And you should be able to talk to that, right? So can you give a quick rundown of how you would secure Linux? Could you answer how you would be a good fit in security? They might not just come out of the gate asking you technical stuff. They might just say, hey, why are you a good fit on our security team? Well, I understand security holistically from the different models and this and I understand the industry standards, and I've secured these systems, right? This is the thing. I understand the industry standard models. I understand some of the federal government standards, and no matter what standards you guys use here, I understand how we secure systems. That would be pretty valid to do on an interview instead of just being like, I'm a guy that knows a lot of stuff and fucking I know everything, right? Which is, by the way, frankly, the attitude of a lot of Linux engineers. I've even been seeing it today in the Discord. Like, being the smartest guy in the room doesn't matter. Being able to prove that you know this stuff because you can talk to it is going to be valuable to you in your career. And then think about security concepts that you think bear the most weight. We were talking about through this whole course. My goal was never to make you like a minion that looked just like a smaller version of me and went out and did exactly stuff like me. I wanted you to understand the security concepts, and you could move on from there to weighing, well, we could be in a completely locked down environment with like zero trust, but nobody would be able to get any work done. So maybe back here in our area that's air gapped off, we allow that to be a little looser so that the compute systems can run. This is how a lot of high performance compute works, right? Like the back end system is all protected, so we can just run out there. It's a fast environment. Still locked down, still secure, but not as much so as maybe the systems that you're coming in from. And you understand those trade-offs. And what would you maybe add to the course as you've read things and worked on things? I have things I want to add to the course. We only had 10 weeks, really 9 weeks if you take this review out. So we couldn't do everything. So those are the things that the topics for this week are. Those topics are down in the Discord for anybody that wants to take part of that. That was the worksheet right there. And there's no lab for this week. All the notes for this week are for you to take on your own, right? So let's go down a little bit. Here's the overview. These are the things that we did. We talked about build standards and compliance. We talked about securing the network connection, user access and system integration. Then we did bash and host and air gapping your system. And we kind of balanced, and we're going to see as we look in here, the theory of all these things and learning about the things and what they are versus the actual practical application. So every one of these things, if you've done the course, is something that you've now worked through, right? You now know how to do these things. By the way, it's all up in the Discord. If anybody wants to go through it, it's all recorded on YouTube and kept forever, right? We updated systems and did patch cycles. We monitored and parsed logs. We monitored and alerted out of a closed system, right? That's a very important thing to know how to do because you don't want to sit at your system all day. You want to take time off and you want to walk away from your desk and you don't want to be in the data center all the time. So you need to know how to send stuff out of a closed system, and you need to know the trade-offs between how we alert and what we alert on, right? Configuration drift, which is an enemy of good engineering, and how do we remediate that? Certificate and key madness, how do we use cryptography to both create an identity for a user and also for a system or a service so that we know that we're talking to who we think we're talking to, and then that we're doing it in both the confidential, nobody else can read it, and in an integrity focused way where nothing can be changed in route, right? That's what a TLS, I guess you would call it, anything in TLS operations or TLS channel would do, is it would both make sure that your data is only being seen by who needs to see it, and then that the integrity of each piece of, at that point, segment is moving without anybody being able to change it. Then we're doing the recap right now. So a couple more things about the goals of this course. This course was never aligned to any one security standard. I didn't say you had to do STIGs. We did STIGs, right? We understood STIGs, but it was a balance of theory versus application. In the review, I'm going to focus some of the stuff back to the Security Plus exam. And the reason I'm doing that is because that's a big holistic, a lot of terminology in there and a lot of things that are valuable. And the course is not designed to get you ready for the Security Plus. However, you'll know 80% of the terminology from the course, for that, which would be the first level of understanding of the course, right? But the idea here was to get you guys kind of ready to be a Linux engineer in a security context and then know how it aligns back to security practice, right? Another goal of the course is to look at things as an engineer. So, right, we're engineers here. And if I go pull up over here on the side, I'm going to pull up my little trusty pen here. The first thing we did as we were talking about this, right? Go change the color here, make it blue. The first thing we did was we have, as an engineer, whenever we do communication, we have these 5 components, right? And the first thing we talked about maybe could have been one right here. Oh, that's a little smaller than I wanted, but this was build. So in week 1, we'll go back. I need to see if I can make that a little bigger. Give me a second here. That pen is way skinnier than it normally is. But anyway, so 1 was build, right? If you come back here to week 1. Build, standards, and compliance. And then we talked about securing that network connection, getting our system ready. So number 2 was right here, right? Was the network connection, this part right here. That was 2, network, right? And I'm looking over here. And then the next one was users. How did we give user space, right, to the system? So 1 was build, 2 was network, 3 was users, 4 was bastions and air gaps. So how do we allow the system to be air gapped? maybe protected that way. So this was 4. And then we air gap the system off away from other systems so they can only talk to it if they were supposed to. And then we had, how do we update, right? Updates. 5 was updates. If I could write, there's updates, right? 5 was updating the system and making sure that you're current and your software is up to date and those kind of things. And then 6 and 7, those both were monitoring. And I don't know why that's so small on the screen today. My pen's doing something. But 6 and 7 were specifically monitoring the system, right? And then 8 dealt with configuration and drift. So how did we keep the system level? And 8 was config. Right? How do we keep the system always the same? So the point is, as you're looking at a model of any type, is understanding that these component pieces were working on all of this. And then 9 was how we allowed access in, right, and communication. So we were securing systems this whole time, right, as we were doing this. Another goal of this course, maybe the last goal of the course that we'll talk about before I go into each of the weeks of review, is to try to prevent a thing that's called a cottywomple. That's the real word. And that's not spelled right, but we'll say that that's fine. And what that is you just look like you know where you're going, but you don't really have any idea, right? It's very easy to try to get in the industry and then just not know where to go and go start spending a bunch of money on a bunch of stuff that I think, quite frankly, isn't going to get you anywhere. So the goal of this was to keep you from ever being in this state where you're like, hey, what road do I take? And he's like, well, where do you want to go? And then Alice is like, well, I don't know. And he goes, no, it doesn't really matter what road you take, does it? But if you tell me you want to be a security engineer, if you tell me you want to understand these concepts, we've touched all of these concepts, all the things that we're kind of talking about in the last few weeks, right? So, Unit 1. What was Unit 1 about? Build standards and compliance. What were the theory things that we talked about that week? It was, what is security? There's this triad that's very common. It's the confidentiality, integrity, and availability. Who can see the system? Who can see the data? Who can change the data? And is the data, or are the data available as often as we need them there, right? That's the confidentiality, integrity, and availability triad. And there's other models, right? But that's a very common one for basic security. And then what's a compliance standard, right? Why do we comply to things? Well, compliance standards can be in your organization. You might have some kind of compliance. You may have an industry type compliance. You might have an external type of compliance that's not regulatory, but something like the payment card industry. We want to take payment cards, so we have to adhere to that. And then maybe you have government regulations, state and local, or big government, or even maybe you're an American company and you want to go deal with the Europeans. Anywhere in the EU, you've got to deal with GDPR, right? That's the the something Data Protection Act or something, some GDPR, which protects the data. But the point is you have to adhere to these compliance standards, right? So we kind of talked about that, and we looked at some of that, and we applied some standards to our systems, and we locked them down in different ways. And then we started talking about what is authority, how does it relate to controls. We'll talk about what controls are here in a second. What are controls and how do they get applied? We'll look at that in the next slide. But authority, right? Like, what does authority will enforce? Like, I can tell you guys, don't chat any right now. No, nobody chat. And you don't have, and you may listen to me. But if you will to do something different, I can't stop you guys from chatting right now. I mean, I guess I could start to drop some controls in place, right? But generally speaking, I can't stop you if you will to do something else, if that makes sense. Then how do I exert my authority then if you're choosing not to listen to me? Well, we've got force. This is very important. You only adhere to somebody's will if you choose to listen to their authority. But if you stop listening to their authority, we have to have a control in place to stop you. So that's that next part. We're going to start looking at the controls here in a second. But what are controls and how are they applied? That's what we talked about. There's general areas and categories of controls, and then there's types of controls, and we'll look at those. And then this is the main thing. This is really important. I didn't want you guys just satisfying requirements and checking boxes and going, my system is stigged at an 85% rate, so we're good. No, I want you to secure your systems and understand how they're secured. Be able to report that back to the security team and up to government customers or whatever, wherever you find yourself doing this stuff. I do a lot of this stuff for the U.S. government, right? Depending on different contracts that I'm on. And sometimes I'm doing it for vendors that then sell their services to the government. But the point is I do a lot of this in the Linux space, right? Some practical hands-on, we use the common STIG tool that everybody in the government uses. It's a very common standard. I mean, people all over the world use it, but you have to use it in government, U.S. government. And then we hardened a MariaDB to a STIG standard, specifically, I believe, around logging and some other things just to kind of see it work, right? So those were the things that we did in week 1. And this is what we kind of got into with the controls. We've got different categories of controls. There's technical things we can do. There's managerial or operational. Often we call these administrative controls. But managerial are things that are coming down from management, and operational are things like standard operating procedures, policies, and those kind of things, right? And then there's physical controls. They actually will like walk you this way or walk you that way, like a guardrail, something like that. Or a little, if any of you guys have ever seen a man trap, that's a physical control. But then we've got different control types. So if something's preventative, like a technical preventative control might be when I log into one of my systems, right? And if I didn't have the key to get in there, I would have been stopped right there on that SSH session. So a technical preventative control may be the challenge password of an SSH daemon, right? Something like that. A deterrent control may be once you get in, you see that you're in a dev environment, and maybe I have a little warning that says this is a government system. You should not be using it. This is a very common deterrent technical control that we have. You must look at it. But if you don't respect its authority, you're just going to go do whatever you want. You're going to be like, that's a government system. I knew that when I was trying to get in it, and now I'm in it, right? That kind of stuff. Detective controls are what are we doing to detect things later? So logs and tracking things that are coming off system. Still a technical control. It has to happen because of technical reasons, but it's a detective type control. Corrective controls are things that we have in place to fix other problems. So maybe we have something that changes a baseline back if somebody changes it, somebody that shouldn't be using root or admin permissions a certain way, they go change it. Compensating controls are, I can't block it this way, so I'm going to stop it another way. So let's say, this is a bad example, but let's say that, I know the user can log in, so then I choose to jail them. I take their permissions away and I drop them in like a chroot jail. That would be like a compensating control. I want to give I don't want to prevent people from getting in. I still want to let them in, but I've got a compensating control, like I put them in a different category. I move them somewhere else. And then directive controls don't really exist for technical because a technical directive wouldn't really make sense because people, again, technical controls are more these things that actually have to happen. Directives are, nobody has to listen to you. Managerial and operational can do all these things as well, but again, they're trying to change the behavior of the user. And then physical is all these same things, but they are physical. So physical preventative control would be like a door. A wall is also a physical preventative control. If you just have a wall around your data center, like you have a little Minecraft wall that nobody can get in with no doors, perfectly secure data center. No access. There's no access to the thing. There's no availability, but you've stopped anybody from physically getting in there. Sure. So then we add a door, right? We put a little door on there, and then we have a way for you to identify yourself as you come in, and now we have all these other things that might start happening. The only one control type, which is a physical control type that hits all of these, is a security guard. Security guards are the only ones that hit all of these, right? And you can go look at those and that kind of stuff, but this is what we talked about the first week, okay? Then we talked about aligning with the industry. We want to do industry best practice, but we don't want to do it just to check boxes and not stop the person from getting in. This guy over here, the black hat, he got in. He did whatever he wanted. It's a great cartoon by Joe Vest, right? We're not just checking boxes. We're not just doing security-related activities and the yakety sax song is playing in the background. That's not the way we do these things, right? So anyways, that's aligning with the industry. All right, so then we get down here. Here's some things that I also think are useful. All of these come directly from the Security Plus cert. So all of these are directly from like their version, their section 1.2 on cybersecurity, but summarizing fundamental security controls. These are the things that we talked about. Some things are a little bit, there's some gaps in there and things that we didn't talk about. We went into zero trust later. We talked about physical security, but we didn't really spend a lot of time on it. So I included this as part of this so that you could think, oh, I need to go spend a little time with some of that stuff. All right. So I need to go spend a little bit of time with some of these things and learn about some of these different technologies. All right. So that was one. Another one is explain the purpose of mitigation techniques to secure the enterprise. We do these things to, as a technical preventative control, to try to keep the system secure. Like, how do we decommission properly without just throwing the old server hardware out back and people can go and pull it out and read it and recreate RAIDs and that kind of stuff? Well, we damage the disks, or we do what we call cryptographic erasure up in the cloud, because nowadays we don't get to actually touch the stuff. Back in the day, we used to put a screwdriver right through the disk platters. We used to drop the actual disks down in a little machine that chunked them all up into little shards of metal. How do we harden systems? We were heavily involved with this all 8 weeks, or all 8 or 9 weeks. But encryption, endpoint protection, installing antivirus if you need it, turning on firewalls and all of these different things, disabling ports that aren't being used, doing password changes for default accounts, always, right? Always do those kind of things. And then removal of unnecessary software. Things that shouldn't be running on your system shouldn't even be there, right? And we build servers for single-use purposes most of the time nowadays, right? So there's that kind of stuff. All right. Another one, compare and contrast concepts and strategies to protect data. We did a little bit of this. We talked about data types. And one of the things I always tell you guys is if you're going to deal with data ownership and you're going to deal with protecting the exfiltration of data, first thing you have to do is classify your data. If you're not going to classify your data, you're just going to tell me all the data is super important. It's going to be difficult to deal with. Typically, data is going to be, or data are going to be for your maybe your HR teams and your marketing teams and your business teams and whatever different teams are out there. And then we can start to set your data up different ways for different access, those kind of things, right? Different ways that we consider data secure. We have data at rest, data in transit, and data in use. And all three of those, we do encryption. Data at rest, always AES 256 or higher security. Data in transit is always TLS 1.2 or 1.3 security. And then data in use deals with how you're dealing with your data in your memory space. It tends to be your developers and software people at that level. But for me, it's about if I'm giving access into something, like if I control a database in some way, my things here are like masking data and any of the ways that we can obfuscate the data, right? And then methods to secure data. We've got all of these different things. We can encrypt the data to protect it. We can do hashes against the data. Now, hashes don't actually hold information of what's in the data, right? A hashing is always the same size, but it kind of weighs the data and makes sure that it hasn't been moved around since it was originally done. We hash things as we move segments around inside of TLS and move data packets across the internet. We actually hash them to make sure that they don't change in transit. That's part of the integrity. We also use hashing for things like logs. So when a log is generated and then saved off somewhere, we take a hash of that log and save it next to it, so nobody can change that log without changing the hash, because it would be different data, right? You wouldn't be able to match them. You'd have to rehash and put it there, and then we obviously aren't going to let people write in there that aren't supposed to. Talked about tokenization a little bit. Tokenization is how you use that data in use so people can't see certain parts of the data. Obfuscation, segmentation, and then giving just specific permission restrictions so people can't see whole rows of databases. There's all kinds of permission sets that we can do in modern databases for sure. So these are things that are kind of more than what we talked about, but they're things for you to go spend time with, right? And again, a lot of this, what I'm doing today in week 10 is aligning the things that we did back with the industry. So there's a lot of gaps here. There's a lot of things for you to go spend more time with if you want to. All right. Summarize the elements of effective security governance. So we talked about policies, acceptable use policy. If you don't have an acceptable use policy, how can you tell people not to do things that aren't illegal, right? Acceptable use policy. I should be able to look at whatever I want on my computer. Not if you have an acceptable use policy that always pops up. Information security policies. How are we securing our data? What are we doing in the case of a business continuity problem? And then business continuity is what are the important things in our organization that we need to be ready to get back working? Business continuity is all about keeping things running. Disaster recovery comes from a good business continuity analysis, right? Disaster recovery is what are we doing when things hit the fan and services start going down, right? Incident response, we've talked about incident response quite a bit, but we're always dealing with incidents in IT. And incidents are anything that happen that we can track that affect confidentiality, integrity, or availability of systems, which is most everything becomes a security incident by that standard. Talked about change management, and that gets a little later, but making sure that configurations are set as you come out of, as a new server is coming down the pike and it goes to run, the configuration does not drift off of the baseline without change management involved, right? And that's a discipline that we have to enforce as engineers, right? How do we do that? We don't let anybody else have admin. We don't let anybody else be root. Okay, standards. Do we give password standards and enforce with a technical preventative control the ability to only have 14 character passwords that have so many repeating characters, and then they always have an upper and a lower and a special character and a number and all these things, right? They're super annoying. No words. You can't have dog in there, or it'll come back as something from a dictionary word. And you're like, oh, really? Yep, can't do it. Procedures. How are we doing change management, and what is our time for standard procedures, maybe routine procedures? Do we just get them auto-approved, those kind of things? And we went through all of this. We talked about external considerations, what regulatory bodies go over your industry, and what legal things do you have to do as far as how you keep your data and maintain it, right? All these kind of things to kind of think about as you do it. Then if you're going to classify your data and you're going to have data owners are the ones that can allow people to see data, right? They're the ones that can permit it. But as custodians, we are always, when you're admin or root on a system, you are always a custodian of data on that system. Why is that? Because I can become any user on the system. I can literally in a Linux box assume any process on the system. I can assume the permissions of that user or process or whatever. And I can do whatever that same thing can do. I have all the permissions of any Linux box if I'm root on it. And if I know that, then I have to take that very seriously. You should take being root or being admin on a system. I'm not telling you have to like kneel down and get knighted or anything, but I'm telling you, it's as big a responsibility as anything. I told my wife, like, I've been the platform engineering lead and I'm, just a systems engineer for high performance compute for like NOAA stuff now. But if I wanted to go in and like shut it down, I could do it. So it's a big responsibility to have that kind of power and to think about it, right? So you got to think about like what am I capable of doing in the system, right? Those kind of things. Wouldn't do that, but I'm just saying you have a lot of power. Risk management. We did not get heavily into risk management, but we understand the risks that are there. We understand how to do risk analysis maybe. We didn't go heavily into this, but these are things to go spend. You spend your whole career in risk management if you want, right? Risk management is qualitative. If there's no numbers, it's just low, medium, high. Quantitative, if it is numbers, we have percentages and dollar figures, and we figure out how often some occurrence per year, typically annualized loss expectancy. And there's a doctor from like the 50s that came up with these, and they are the way that we basically do everything, the ALE and the ARO, probability, likelihood, and then we make these things. I don't think I didn't actually go into that, but I have talks where we talk about risk management and stuff for people that want to do that. We keep a risk register. Typically, we have software for that in an organization. And then who owns the risk and what's the threshold before we need to reevaluate the risk or trigger something to stop whatever activity we're doing, right? An organization has a risk appetite, or sometimes what we call your security posture will determine, are you trying to be conservative and just keep making money, or are you trying to expand into other markets? So you're maybe doing some things that are a little more risky. And what are the security considerations of those things? We have all kinds of things to consider, right? What can we do with risk? We can transfer it. We can sell it. Transferring risk or selling it is insurance. I buy insurance. They assume the risk, but then they get enough people doing it, and they're just collecting money hand over fist. I've worked a few times in my career for insurance companies, and they just basically bring in money hand over fist, right? You can accept risk. You can go, well, that risk is always going to be there. You guys accept risk every day. Every day you go out and get in a car and drive around or go in public in general, you're accepting the risk that something might happen. You're just accepting it. Do you wear a little like suit on you that like has like little pads? Like, have you guys ever seen that thing when you fall off a bike, like a motorcycle, and they'll like inflate as you're falling? I've seen those. They're kind of cool. Some people want that type of risk. That's a mitigation, right? You can avoid risk. You can just stop going out in public. I think there's a term for that, like agoraphobia or something, right? Like fear of open places. But then it was risk registering. And then we talk about business impact analysis, thinking about that business continuity plan. We start talking about business impact analysis. How fast do we want to be recovering, and what point of data back from the incident do we want to recover the information from, right? Mean time to repair, mean time between failures. These are all things that start to feed into our risk of the system, right? Okay, so let's keep going down. Unit 2, again, this is all review, so all these things are from the different weeks. We're not doing the hands-on right now, but we spent hours and hours. Some of you guys spent hours and hours working together on these projects, right, and these things. Unit 2 is now, what did we do there? So the first one, we built the system, talked about securing it, and in Unit 2, we connected it to a network. So the theory was protecting the ingress to your systems. Your systems have TCP and UDP ports that can be opened. There's 65,534 ports, right? It's the number is 65,536, but you can't use the bottom one, can't use the top one. Bottom one is unusable, and top one is, I also don't know why. It's not like networking. They're not the broadcasts in the network, but they're still unusable. Then we talked about sysctl and kernel interactions with your network. So there's all kinds of things. If you come here and you do like a sysctl-a grep for like IPv4, you'll see all of these ways that we can change the way that our system, our kernel, interacts with the network interfaces that are trying to come into our system. We can turn off accepting broadcasts. We can turn off listening to ping. We actually did that. We stopped ping. We told the system not to listen to ping anymore. Tried to ping it, can't ping it anymore. Can still SSH to it, port 22 is open, but it will not respond to ICMP traffic anymore if you turn that off. So I pull that, I talk about all those things to say there's a lot of theory there to go spend time with. And you say, well, Scott, how would I know? There's all those things. How would I know them all? Well, there's standards that are out there. There are best practices called STIGs, Secure Technical Implementation Guidelines, that we can follow, right? You don't have to go it alone, right? You can be like, Link. He's told, don't go alone. Take this, and he takes a little sword with him, right? You get the little wooden sword in the very first Zelda game, and Link can do all those things. But you can do sysctl and kernel interactions and determine what you want to allow or not allow across your system. I think you guys probably know this, but any Linux box out there can immediately act as a router if you want it to. You can make it forward packets back and forth. You can do all kinds of things, or you can turn that all off with sysctl. Then we talked about DNS security and etsy-nsswitch.conf and how that affects what our system talks to and what our system trusts. And there's a lot of little DNS things that can happen in the world nowadays. So where do we trust for DNS, right? And then tools and look at open ports and activities crossing our interfaces. We talked about ngrep and TCP dump and all of those kind of things, right? Yeah, the game was called Zelda. The character was Link. Yeah, I know. I grew up with it. I don't make that mistake. I know the difference between the two. All right, but then the practical application was we stigged a RHEL 9 system. And some of you guys spent hours and hours stigging it all the way up, trying to get up in the 80s and 90s as most government systems require. We turned on Firewall D and set up new services so we can allow traffic in and out of our systems. And then we reviewed all the network-related stigs in an automated system, in an automation for remediation of stigs. So you don't have to do all the stigs by hand. You can run Ansible playbooks and you can stig a box all the way up, but sometimes we got to back it off. So we looked at that. And again, I didn't do any of this. I didn't make you guys do any of this to see if you could be a fucking robot. We've got the automation. We can hit the button and stig a box completely. The goal is if you understand the trade-offs of the things and can you make that valuable to an organization, right? Because you understand what you're doing. Can I harden a box and still accomplish the purpose of that server or that box or whatever we're talking about, right? I interchangeably use those terms, right? So aligning the network with the system, given a scenario, apply security principles to secure enterprise infrastructure. So all of these things, right? Infrastructure considerations, where are we putting our devices? Security zones, are we in a DMZ? Are we outside? Are we internal network? Where are we putting things? What is the attack surface of a server, right? We were talking about all these things. Connectivity and keeping our system up. Are we bonding interfaces so that we have higher connectivity even if a device fails? Devices are always going to fail eventually. So do we have a way to deal with that and to still remain active? We talked about failure modes, fail open. If the system fails, does it turn back on or does it stay open? Or if it fails, does it automatically turn off? The right failure mode for most servers is fail closed. Turn them off. We'll turn them back on when we get to them. Fail open is always going to be the failure mode of a data center or a man trap or any of those kind of things. Because just understand, as a business, If you lock somebody in a man trap and there's a fire and they just smoke inhalation and burn to death, and it's just a melted mess when you get in there, you're gonna get sued pretty fucking bad for that. So don't do that, right? Anyways, device attributes, active versus passive. When you're running some redundant systems, are they active or are they active passive? So are they both accepting connections, or is only one accepting connections and the other ones are waiting? And there's different considerations for how we do those, right? Inline versus tap. This is more of a network thing, but inline means that the device actually sits between the other devices and there's no way through it except by that. And then a tap or a monitor is where we what we do called mirroring a port, and then we allow the traffic to go to both, and then it just tracks and logs. And a lot of IDSs are tap monitor. If you ever set up a LBGW, so a load balancer gateway in AWS, that is a tap monitor on your system for all the data that's coming in, right? Network appliances. We're not going to get into this too much, but I'm a big fan of knowing what a jump server is in the Linux world. Can I get to like my P01 Jump 01 server, and then can I jump off into any other part of my network? It's very important, right? I can jump into this and then have permissions escalated and then go do things that I need to, and then jump out of that connection when I'm ready. So there's a bunch of things here that we kind of touched around security, and some of these things are going to come up later, so we're not going to hit them too much, but it's good to understand that, if you were trying to go get your Security Plus, you would need to understand these components as well. All right. Given a scenario, modify enterprise capabilities to enhance security. So we understand firewalls. We understand the rules of a firewall. Typically deny any and then allow the ones that we want. Access lists are going to allow traffic to flow to certain destination ports or from certain destinations, right? We can, or certain sources, as it were. We can go through that. All the ports and protocols, you don't need to memorize all those, but it's a good idea to know where to go reference them. In any Linux box, it's always Etsy services that'll tell you what the services are, right? IDS, IPS, intrusion detection versus intrusion prevention. Are they looking at trends or are they looking at signatures? So signature-based intrusion detection, are they know all the things? So if I come over here and I did like, I think FreshClam will do it. It'll tell me that the database is up to date, and there are, what is that? That's 6 million, that's 6.6 million signatures of viruses that this thing knows how to look for, right? 6.6 million. So when you're looking at a virus signature or signature in the network for an attack, a signature is something that's been seen before. A trend is something that's never been seen before. A signature is something like, this thing tries to pass through and it's got certain flags set on it, or it's got certain executable code, and that's going to be, whatever it is. And then for trends are going to be, maybe you're watching traffic spike. A bunch of TLS connections, embryonic half-open connections, are trying to go to your system. Somebody's trying to do some kind of handshake BS. Now, we've solved most of the handshake stuff in the early 2000s, right? Server connections and the SYNAC attacks and those kind of things. But trends of that happening can be something that triggers something to stop. Or a lot of trends that we look at nowadays are bot activity. Those are things that you can look into with intrusion detection and intrusion prevention systems. Intrusion detection merely watches and alerts. Intrusion prevention changes some configuration on the system. There's a whole bunch of these. Intrusion detection are your logs and your filters and your SIEM solutions. Intrusion preventions are your typically like your fail-to-bans and your firewalls that are actually blocking, like your web application firewalls that are actually blocking traffic that's coming in too fast or doing certain things in JSON and that kind of stuff. Web filters can filter at layer 7 against a bunch of different things. Operational system security, do we have group policy? Do we have SE Linux or one of those type of things? That just means additional labeling on the system, right? Group policy, by the way, is a Windows term. So in our Linux course, we didn't really focus on it, but it is a valid thing to understand if you're going to be heavily security for an organization. And you might say, well, I'll never touch group policy. You won't directly, but your Linux boxes that do federated access or do trust into Active Directory and do LDAP, they're not going to get true group policy true. Not going to touch you directly, but you are going to get groups from the system. So it is probably a good idea to understand some about group policy, even though you're over here in the Linux world not really doing Windows directly, right? How do we implement secure protocols. We make sure that we we select the right protocols, so we don't just use FTP and TLS. We use SSH and secure FTP and different stuff like that. Ports, we don't change ports to obscure them because people that know how to scan for ports are going to see them anyways. What we do instead is we block the ports with all the best practices, and then we monitor port activity to either be cut off or to block, those kind of things. So that's the safest thing. Block, only allow a couple of ways in, the ways that are supposed to be connected to, and then monitor them heavily. That's what we do. That's also how, all the way back to medieval times, you had a castle with a big wall and you can come in through one gate and the guards can stand at that one gate. Guards didn't have to run up and down to stop everybody coming in from anywhere. You had to come in one ingress and one egress point. Super easy to watch people come in and out of a gate, right? And then transport method. How are we moving that data around? The common standard nowadays is TLS, transport layer security. I've heard of some other ones, and people were talking about DTLS, and you can go look at those if you want, but I'm just going to tell you the enterprise standard, the way that we move data is always going to be TLS, right? That's how we're going to move secure data. And then there's some email stuff and some other things that you can kind of look at. All right, so let's go to Unit 3. What was Unit 3 about? We were talking about giving, so now we've built the system, we've put it on the network, now we got to let users in. Like if we're going to have a system that is accessible by others, right, and usable, we have to have methods for users to get in. So on our Linux systems, we looked at connecting to LDAP, Lightweight Directory Authentication Protocol, right? And give access management, identity and access management type tooling for users to get into our system, right? So we set this all up. And then we started using pluggable authentication modules, so PAM modules, to allow or disallow things to happen as people logged in. And PAM is all the authentication of all your applications in Linux. Go through that, and then it can go check, hey, yeah, this user is using the right password. Hey, yeah, the user is the right user off of the Active Directory. But pluggable authentication modules control all that, so no applications can go directly to any of those services. It's a layer of abstraction that acts as a security choke point. Same as anything else. You can't go around them. You have to go directly through them, right? You got to talk to them in the way that they understand. And then we talked about user creation with etclogin.defs and the user numbers and all that stuff. So then what did we do in that lab? We set up PAM and integrated it with SSHD. Okay, yeah, we did do that. And then we did the PAM STIGs, so looked at locking down PAM and talked about the trade-offs there, right? And then we created OpenLDAP implementation and connected via SSSD and allowed our system to see users from LDAP. And that was kind of a cool little project for a lot of you guys. Some of you guys that did it, I'd say maybe like 10 people out of the original 100 or so that said they were coming made it this far. And they went and they connected and they did all this lab stuff and built these things. So the topics that kind of go on with that is we got to understand adding and removing users from the system. If we're going to have users, we're going to have a place to keep track of users. It's not always us as Linux engineers, but it's important to know that that is going to be out there. If we're gonna make users have an identity and then we can authenticate that identity, we can then give permissions, authorization, right, to do things. So there's that. We can identity proof, so we prove that somebody is who they say they are. And then federation. Federation is the idea that we trust somebody else. So federation of, if I allow federated Google services into my systems, you could come in and be like, hey, my name is John Hancock, and Google would know you as John Hancock. And you would try to come into my systems, and then you would say, hey, well, Google knows me. And then Google would say, yeah, I know him. And then you'd be able to come in. But that's federated authority. And we could set that up for Google, for Facebook, for a bunch of different services, right? From federation, a separate concept that's very common nowadays is single sign-on. This is the idea that I sign into like Okta or one tool. Okta is a very common one. But I sign into one tool, and then I have access to all of my applications right under that tool. But the application directory is all inside of a browser, and then the actual application is in the browser. Everything's just done in the browser nowadays. And there's security assertion markup language, SAML, that tends to be used there. We also use OAuth and OAuth 2, and that's going to be when we start using like little tokens and then checking things in and providing our services around that. In this week, I showed you guys didn't have to do this lab, but I have a lab where you go and do that with Vault and Ansible. So Ansible will check out your credentials from Vault. It'll go and it'll prove that it is who it says it is, and it'll read some data out of Vault as though it were reading. Actually, the strings that we're using are, it would be like if you were going to stand up an environment and connect like an application to a backend database server. You can get the connect string and the username and the password right out of Vault without ever having to know it. Your pipeline just reads it in real time, and then whatever the devs have and whatever you have, it's just going to connect. You don't have to, I never have to touch that data. My system can do it all automated, right? Could I touch the data? Sure, I guess, but I have no desire to know more things in a system than I need to, right? Interoperability. This is a big one. Attestation. When you're adhering to anything, any standard, attestation is the first time you do a scan or a test. You attest that this is your level. Then typically a third party will come in and verify your attestation, right? This is just in general. Access controls. How are we giving users access to things? Multi-factor authentication. Biometrics are something you are. Hard or soft authentication. You can have tokens, security keys. The different factors are something you know, something you have, something you are, somewhere you are. That's a big one. There's a thing in Azure. If you were to ever log in from like Phoenix, Arizona, and then turn on a VPN and then log in from like Paris, Azure would flag you and make you re-authenticate. And you say, well, why? Because you just did a thing called impossible travel. I can't be in Arizona in the morning and be in Paris by noon. That's impossible travel. So those are kind of things that happen. Yeah. There's a whole bunch of those. Yeah. And then password complexity and how we enforce it and all that kind of stuff, right? Just-in-time permissions. We check out our permission. I don't know if any of you guys have dealt with this with like CyberArk. You check out your password for the day, and that's your user password for the day. A lot of us root users have to do that. We don't, I can't be compromised while I'm sleeping because my password's already been changed in my organization. Did you guys know that? If you found a way to trick me into giving you the password that, again, I didn't even know for today because it was just something I kept in a note somewhere, it would already be compromised. And it would already be changed. And even if you compromise me, you wouldn't be able to get in. And then you wouldn't be able to elevate your privileges anyways. And that's not even talking about if I have a second factor of authentication. Like, you've got to get my phone away from me, or you've got to get my little YubiKey away from me, right? Those kind of things are there. So that's aligning that with the industry. So let's go to Unit 4. Unit 4 was Bastion, hosts, and air gaps. And this one was probably one of my favorite ones to make the presentation for because we had all the little penguins jumping everywhere. And I thought it was hilarious. But the theories that we talked about were jailing users. We talked about bastions, air gap systems. And then if we're going to air gap systems, we have to control the ingress and egress point of the system. How are you getting in? How are you getting out of the system? There's a lot of practical application we did. We built a jail with chroot for a user. Then we give that jail the basic services and commands so they can do what they need to. And then we built a bastion to allow the user to pass through and get into resources beyond. This was, I believe, no, I didn't. I only did the one drawing. This one, I think people really liked as well. There was a lot of chatter in the Discord around this one. And this is all up in Killer Coda. So you could do these even if you didn't want to be part of the course. Some of the things around this, aligning this with the industry, this is an actual deliverable right here. This is a generic one, but I give this to actual customers. This right here is a network boundary example for a common type of diagram. This is a common type diagram, network boundary example, and a customer wants to see where does the outside network, some gateway switch that we have, connect into our supercomputer that we're building, or high performance compute, right? They use the terms interchangeably. A lot of people in the industry like to call them supercomputers. So the gateway, if you're on the outside, you can get to the web application firewall, the AI ML nodes, or maybe like the data valet nodes. Those are data movers sometimes. Depends on, you call them whatever you want. That's where your network ends. Once you get to there, web application firewall, you can maybe make a request to a service here, and then maybe that service or something that you're talking to is like open on demand, and then open on demand can put jobs on the network, and then those management switches are talking to the individual nodes or compute nodes in the system, and those things are out doing whatever. But you're just standing here submitting jobs to this web application firewall. You're never getting into the network as a user. Never. You're just submitting jobs here. Here you might be logging in as a user and doing more like PBS or Slurm or Platform LSF or whatever tooling you're using for your job submissions there. And then when your jobs are done and you need to pull all that tasty data out, you move over into your data valet nodes, and now you have access to the data on the system in those nodes, and this is where you can pull the data out back to your servers or whatever. Or maybe you do an SCP from there to pull data out. And these are typically higher speed, multiple, bonded interfaces and those kind of things. But this is, and then internal management of the system here, and the back end high speed InfiniBand, typically like a 200 gig or 400 gigabit per second network, right? Pretty fast. But we do all of these things, and this is kind of the things we want to know around air gapping users. Like, well, how do we allow a user right here? And we did that securely with a tool called jails, right? We did jails and built bastions. All right. So Unit 5 then. What's Unit 5? We did updating systems and patch cycles. We talked about package integrity and how do we verify that the packages are from the person that they said they were, whatever vendor it was, and then also that nobody's changed them, right? We built our own trusted package repositories. So do we have internal repos? Because our systems don't have a way to go out, right? Especially in a gapped system. So we're going to have only repos here. How do we automate patching? If we want to allow systems to be patched and we want to automate patching so that things work without us having to touch everything every time. And then we talked a little bit about EPEL, extra packages for enterprise Linux. And these are things that shouldn't probably be used if you need support for them. So if this is something like just, your admins are going to use, or like you're just going to use for some extra tooling, feel free to use it. But if it's going to be something that's going to become part of like a major system and needs to be supported, and you're on a government system that has to have support from a vendor, extra packages from enterprise Linux are not going to cut it. You can't use them. They don't have somebody for you to call because they're not vendor supported. So that's the thing to think about. So in our practical application, we downloaded some custom software from a tool called Mellanox, and we went and looked at how you would do that and how you would pick I showed you guys in the little picker tool that they have, how you actually do that. We built a repo locally, we shared it over a network, and then we connected to it both times from servers. We connected to both of them right there, and then we actually updated packages from there. We saw which repo was active and which ones we had turned off, and then we looked at how, even though you're using command line DNF to allow or not allow them, all you're doing is changing files in etc yum.repos.d. That's all you're doing. You're modifying a package with a tool, or a file with a tool. And I tell you guys all the time, know what your tools are doing under the hood, because then if your tool ever breaks, you can still go do it by hand because you know what the tool was doing, right? And then we ran a simulated enterprise patching via an Ansible playbook up in one of our Killer Coda labs, right? So patch cycles look kind of like this. DNF yum is going to read from the config. It's going to go look through all of its repositories that it has. It's going to make sure that the keys are good and that the metadata shows that the packages are signed properly by the GPG key. Then it's going to come down and it's going to install any of the things that you tell it to, or it'll just download all the metadata and hold it in var cache DNF, and then make sure that when you want to go when you want to go search or pull that data, it's got a local cache. But if you want to, you can do DNF clean all, and it'll clean all your caches out, and then you'll have to go pull it again. It takes just a little bit extra time, but sometimes you want to clean out caches every time you do patching. That's a thing that we tend to do. But just always let the systems pull again. Don't ever remember anything. Always pull new stuff. All right. So anyways, patching in the environment or in the enterprise might look like this. You've got some vendor patches. Now, you could be an organization that builds your own patches, but I'm going to tell you, probably unless you're Red Hat or Oracle or somebody like that, you're not doing that. You're probably trusting some third-party vendor, Red Hat, Oracle, Microsoft, whoever it is, and we pull everything down at the beginning of the month. Typically, this is the beginning of the month activity, sometime in the first week. I like to do it on the first day of the month. Download, and we just harden all the patching. And by the way, I'm a Linux guy, so I don't know what the Windows thing is. It's like second or third Tuesday of the month. There's some very common one of those. Sure, that's when they do it. But we pull it down, let's say at the beginning of the month, and we're going to solidify all those repos that day. Then that's going to be what we get for the next month. We're going to check that in. We can do some risk analysis. You probably don't have enough people on teams to do that. You'd have to be a very big organization to do that. But what we do is we then deploy them to dev, and we do all of our validation testing. We do our regression testing. We do our smoke testing. Smoke testing, make sure things come on without all the smoke getting out of the system. Regression testing, make sure it works with old versions, right? Just make sure things work. There's no fixes. There's no problems. Do we need to roll anything out? Then when we're ready, we push those up to like our test QA environments and patch those. That tends to be, this first one is typically like 2 weeks. For me anyways, it's 2 weeks. This one is the next week. We go to our test QA environment, and then we get down to where we go to sometimes pre-prod, sure, but typically right to production at like week 3 or week 4 of the month. Validate, make sure everything's good, check all our patching, roll back if you really have to, but typically rollback is only on some machines. You're never going to be able to roll back everything. It's too much to do. And then we'll say patch cycle's complete. Did we patch the kernel or did we not patch the kernel? Do we reboot or not? And if we reboot, then we have to know how to do rolling reboots so we don't take customer-facing downtime. All of these things, right? Sometimes we patch in batches and all that kind of stuff. There's all kinds of other things that can happen here, but this was the high-level steps, right? The high-level things that we do. All right, so that was that. Aligning with the industry, explain the security implications of proper hardware, software, and data asset management. So for this week or for Unit 5, we were talking about how we procure the software that we need, how we trust the vendors and then download only the things that we should. Assignment and accounting, ownership and classification of things. We need to have good inventory. If you don't have good inventory, you're not going to be able to patch anything. It's just not going to work. You're going to patch 980 servers out of the 1,000 you have, but you didn't have 20 of them on your list. That's poor management, right? That's poor inventory. Enumeration, being able to count up through all the things, counting all the heads on, I don't know, sheep or something like that if you keep sheep, or counting all your servers, making sure they're all up and available. That's enumeration, right? And then if we're getting rid of servers, if they're at the end of their life cycle and they don't need to be patched anymore, you need to close them out, destroy them, decertify them. Do you need to pull any data off them before they go down? Typically, we keep servers in a decommissioned state for about 2 to 3 weeks, depending on organization policy, in case somebody needs to get data off them again. Now, that all being said, we tend to not leave any data on Linux servers anyways. We try to have them all up on some type of network share anyways, but that's that. Another big part of this, when I talk about disposal and decommissioning, you should always pre-check. If you think you're patching 1,000 servers tonight, you should pre-check those servers before you start patching. Because what will happen is you'll get to the end of a patch night, and I've seen this happen. I've been part of teams where this has happened. You get to the end of the night, and only 980 of the servers are up. And we're like, shoot, 200 or 20 of those servers are down. Why? Did anybody check them before we started? No. Now we got to get those servers up. So we're turning servers on that were off already, but we didn't know that because we didn't test. And then people are like, no, we got a change ticket. Those were all turned off. And you're like, so what's better is to check things beforehand and have a list. Yeah, I thought we were doing 1,000 servers tonight because that's what the management team told us, the configuration management team. But hold on, no, we can't patch all of them because 20 of them were already down. We'll deal with that shit on Monday morning. I'm not dealing with that on patch night, right? The question is, on the note of patch and package management, do you allow all developers to pull their own stuff off package managers or run a central repo? Yeah, no, we don't. I don't ever allow developers to do that stuff. Typically they have to use our repos if you're talking just the straight Linux stuff. And my background is I used to maintain a set of servers for AAA where we had about 200 dev teams. And yeah, they can have their own repos and they can pull their own stuff down, but like third-party software all has to come in through us or the middleware team typically, yeah. So, yeah, they can't pull anything down. They don't even have root on the boxes, typically. It's sometimes down the dev environments will give them limited root on some of their short-lived systems for sure. But identification methods for problems, you can do vulnerability scans. This is all red teaming stuff, right? You can do analysis and look up CVSS and CVE. So a lot of this stuff comes from third-party tools, but if you do run your own red team, you can scan a lot of this stuff yourself and then give reports for how far in or out of compliance your organization is, right? There's vulnerability response and remediation. So we patch. Maybe we have some insurance that we pay for. We transfer some of that risk again from before. Maybe we segment things and keep things secure so that if we have things air-gapped, a lot of times we can go on a slower patch cycle with them because they're in a controlled environment and we know why they're kept back. stability is the, we go for stability and speed for them instead of like security and exposure, right? They're already locked down internally. Compensating controls. If let's say I can't patch some open port in some way for some reason, well, I might turn the firewall on and just leave that port off until later. I protect that port with a compensating control in some way. And that's the thing that actually can help out in some things. And then we can get exceptions and exemptions. Sometimes somebody says you cannot use this service because it's insecure. And you're like, well, that's that, or we don't do business anymore. Then the government typically, but also your companies are going to go, well, if that's the choice, do no business until this is patched, or continue doing business but know the risk. They're going to make an exemption for something and be like, yeah, we realize that Log4j is terrible, but we got Log4j. Let's mitigate it other ways. Make sure that we're watching for those attacks through maybe our web application firewall in front, and then we track from there. So, and then report. How are we reporting this up to the business? I'm a big fan of using STIG reports, but also reporting up through like CVSS tools and scanning, depending on who your vendors are. And there's a bunch of different vendors that do scanning like this. Qualys is one. Who are other ones? Qualys are some. Tenable Security, which runs Nessus. Those are ones that kind of do the scanning. You could do that scanning yourself, though. It's just something that would take a lot of effort and a lot of engineering hours, right? But these are all things that are there. All right. So Unit 6. What was Unit 6 about? We talked about monitoring, parsing logs. The next two are going to be about logs. Monitor and parsing logs. We talked about logs and their role in system security. We want to get the logs off in real time, get them off the box. Then we talked about the RFCs that govern log structure. There's RFC 3164, which is the old Unix BSD style logs. And then there's RFC 5424, which is the IETF, Internet Engineering Task Force, more modern way of doing logs, right? Both of them are still valid. You're still going to see both of them. Did I actually show them? I actually showed them here. But log aggregation, get logs off and send them to a central location. Loki, Splunk, Elasticsearch, these are all OpenSearch instead of Elasticsearch. These are all things that people use. SIEM is security, information, and event monitoring and parsing logs different ways. We talked about analyzing real-world security events, log data, and query languages like LogQL and some of these other ones that exist. And then we talked about anti-patterns for log management, right? Don't just, pull in everything, even things that are unrelated, right? So we'll talk about that. Then some practical stuff. We talked about sending logs with our syslog. We did that in an unsecure fashion when we secured it later in the class. But then Kafka logs into Loki, and we did those logs as well. So here's the log standard for, this should be, 3164 for BSD. Looks like this. It's got the day. Does not have the year. This doesn't keep the year. Then it has the time, and then it has the host name, the process. They're all up here, by the way. The process name and the process number, and then some short little message. So there's all those things there. The tag is the process owner. That's the owner of the process, and that's the process ID. So there it is. 5424, again, a little nicer looking, and I need to move that off so you guys can actually see that. But that's the standard at the bottom there. It's very similar, except it has the time in 8601 format. So ISO 8601 is the format that you'll see for that one. Okay. Same message, same basic message put into that one, just a little different. All right. Then System D, this is one we talked a little bit about. This one doesn't get sent off, but this is one that is very good to understand. And it's kept in you can't look at it in text format. It's a binary format. So that makes it more efficient for storing the information, but you need to use a tool like Journal CTL to actually read this one. All right. So aligning that back to the industry, we explained security alerting and monitoring concepts and tools. It's very important that you understand you've got a closed system. Even your laptop, even your phone, it's a closed system. And if you're not near your phone and your phone starts alerting that somebody's calling you or some message is going off, that's its way of alerting you that something's happened inside of the closed system. Well, our corporate systems are the same. Unless you're going to be connected into that thing and jacked into it 100% of the time, looking at the terminal, I couldn't imagine doing that. It would fucking kill you, right? Like you just have a grabber in your office and fall over, right? So we want to leave the system and go have our lives, but have the system still be able to alert for emergencies. Like if one of the servers just turns over and is upside down in the water, we need to fix that, right? Also, if it's in water, we should fix that. But monitoring computer resources, systems, applications, infrastructure, systems, we're always monitoring for the big four, right? We always talk about the big four: CPU, memory, disk, network. Applications, are applications taking too long? Are they throwing too many errors? Are they, whatever they're doing, they start to hit a threshold based on what we call SLIs, service level indicators, we need to know. Infrastructure, are critical pieces of your infrastructure down, and are you losing money because processes aren't happening in your company? These are things that need to trigger. Activities for monitoring, making your logs all go to one place so you can churn through them, alerting out, maybe scanning and reporting and archiving things. These are all activities, right? Tools, we might do secure content automation protocol, SCAP. SCAP is a way to run and secure your systems. We might benchmark the system so that it has certain things set. Agents versus agentless is always the topic of more agents on a system do bog the system down over time. But sometimes we want agents that use less than 1% CPU, like Node Exporter uses a very small amount of CPU, and it's very good for getting all of the information off for tools like Prometheus to come along and scrape, right? SIEM, security information and event management, so we can track what's going on inside of our systems and maybe look for patterns, right? And there's all these different things that we kind of talked about or need to think about if we're going to do this in the industry, all right? So now Unit 7, more monitoring, but with alerting, right? So now we talked about sending a message out from a closed system. That's the definition of an alert. We talked about monitoring architectures that are out there. You've got push and pull monitoring, and you've got time series databases, TSDBs, that are optimized along only the concept of time. That's the only thing they care about. And you can then query windows of time, from today to 18 hours ago. See all that stuff, right? This is exactly how Grafana looks at things. I do actually have my systems up, but we're not going to look at them right now. But in my home and lab environment, we can look at any of the time windows that we want to see when something was happening, right? Then we need to do pertinent, actionable alerting of things that are wrong in our system, right? And send that up. We need to know about information flow versus security trade-off. We want the data to flow, but we need to be secure about it. And then intrusion detection is like, it's like that videographer on National Geographic. He'll watch the little baby turtles get eaten, right? But then an intrusion prevention system would stop it. I saw a video the one day, there was a little baby turtle crawling, and this crab grabbed it and pulled it under the sand. And the guy watching was like, no, that's not. And he pulled the little baby turtle out and let it go to the ocean. It's like, that would have never happened in National Geographic. We would all been like, I would have saved that little guy. But no, this guy actually saved the turtle. He's like, no, sorry, crab, you're going to have to go get one when I'm not looking. And he let the little turtle go. And I get it, right? But that's the trade-off, intrusion detection versus prevention, right? There are trade-offs there too, because when you're letting systems do things automatically, there's always considerations. We get into that with the configuration. When we overlay something back to the original configuration, you will always break something. It's a fact. You have to break something. Somebody changed it to fix it, and you overlay it back. You're going to do, well, that's in the configuration drift part. Anyways, practical application, we did fail to ban and we locked out users. We did monitoring with fail to ban logs, and then we sent an alert into our Discord. And some of you guys, even people that are on channel right now, did this. You guys sent alerts up, and you saw the alert come out. And I'm telling you, I know it's silly, but it's that quote from Predator where Dutch looks and says, if it can bleed, we can kill it. It's one of the most mature things I've ever heard. If something has blood pumping through it and you can get enough of that blood out of it, yes, that's true, you can kill it. Well, it's the same thing with a system. I only need to see the system send an alert once to know that I can alert on anything. I just need to figure out the thresholds, and I need to figure out how to do it. Then I need to tune it back so it's not just sending so much alerts that it causes us problems. And this is how we track and do these things. Okay. So in aligning with the industry, we've got so much log data that it becomes noise. We want to get all those logs to one place and then have the system churn through it and figure out what's wrong and look for patterns and those kind of things. And those things are your SIEM solutions, right? Data sources, scanners, reports, dashboards, packet capture. There's so many things that will give you information. But one thing that's very important to know is you can never go back and regenerate logs. Like if something's gone, or if you lose packet captures, you'll never capture that again. It's gone forever. So that's very important. Keep going. Unit 8. This was the configuration drift management, right? So CMDB, configuration management database. Guys, even as I teach this, even when I taught this, when we did it, as everybody was together, I was trying to really emphasize, like, as engineers, we don't necessarily like configuration management people. I've gotten into so many like locked in fights with these people, like almost fist fights with some of them, if we're being honest. Because configuration management people are there to make our engineering jobs better, but they forget that that's what they're there for. And over time, they think their job is just to trip us up, right? It's kind of like one of those movies where things were all good at the start, but then they turn like dystopian. It's the same kind of concept with CMDB teams. But we have system baselines. We push our servers off into the night working perfectly, and immediately they start to drift. I tell you guys, you release 100 servers out into the wild. By the next day when you get back, they're all going to be different. Some things have changed on some of them. Configuration drift and the impact on security operations. When things drift off of the original build book and they're not captured in the run book or the build book, if you then have to redeploy something from the original build book, you have now reintroduced all of the security considerations or all of the security things that have happened since that original build book. This is why when we talk about configuration of systems, it is so important to it's like a firm grip on this thing. We are not letting this be something that's slack. We need to know this stuff. File system integrity, what's changed? We use a tool called AID, which is the Advanced Intrusion and Detection Environment, and we can keep anything from changing. We can monitor or remediate drift. So monitoring drift, we just track for things to change. It's very simple. We use Ansible for it, something like that. But we can remediate drift, but we will almost always break things that people have fixed. So there's considerations for both of these, right? So the goal of, again, this course was to align you with what you can do and what is there in the industry. But then, job description drift. Yeah. Practical application for this was we did some change management, looked at some STIGs again. I made you guys look at STIGs the whole time because it was a good activity to get familiar with how we report and talk in the industry, right? This is, you will not get a job doing security with like the U.S. government or with companies that deal with the U.S. government without like understanding how STIGs work if you're doing like tech type stuff. Because STIGs they're so big. They're just such a big thing. So getting into that and like kind of jumping in and seeing that the water is warm and seeing how the tool works, that's valuable, right? And if nobody ever showed you to do it, it's free and out there. You just have to go and practice with it, right? So that was, again, the practical application. Then we did AID, and we actually changed things in our environment and saw, oh, shoot, AID does have tracking on that. And then we looked very quickly that in stateless nodes, AID doesn't work. So like in our lab, you can set AID up, but you'll never see a drift because when you turn the machine off and turn it back on, you've lost the database. So that's an unfortunate thing. Then we use Ansible to fix drift on web pages. Somebody in our company figured out our little Ansible deployer, and they were changing things in the company, and then we just came back and kept blowing it away. That's what we did in that lab, which is actually one that's up on Killer Coda that you guys can play with. And then optionally, we use Ansible to stamp facts onto a server and then a CSV to report out. And we did that to show that we could build servers and make sure that they are stamped with all their information. So then when the Ansible playbooks come later and patching comes later, everything can be known about that server. It's almost like the server has a little note on its backpack when it starts, and it's like, these are all the things about me that are going to be pertinent during this patching. And that's a very, very useful thing as a systems admin because we try to trust the configuration management database. We try to trust that thing. But I'm going to tell you right now, anybody in the chat that's worked with one, you know that thing's always out of date. There's always something wrong with it. And because of that, we sometimes need to have our own checking. And I like having that control. You guys might, if you ever work with me, you'll be like, man, Scott's very good, but he's also very controlling about his stuff. Well, if my name's on it, it's got to be right? I just can't. I've tried, like I got mad one time years ago in my career. I got a really bad review from a manager when like everybody, well, I got multiple awards that year for cash from the company. I got like multiple things at Lockheed. I had this manager tank my career, right? I got really fucking pissed. And I tried to just be a shitbag. I couldn't. My work was still good. And the reason was because I couldn't have, I can't do it. I've tried. I legitimately was just like, what people now call quiet quitting, I tried to do it. But instead, I just kept doing really well. And then it was funny. They tried to lay people off, and one of the program managers said, "No, I'll keep Scott on with my own money." This was in like 2000. This would have been like 2012, but like we were like economic downturn still, right? They were losing people, and then one of the program managers said, "Nope, Scott's staying." It was for Nagios stuff that I was building, but she kept me with her own money from the program, even though my boss was going to let me go. So kind of funny, but I don't care. This is what that kind of looks like. We build systems, right? Engineers build systems according to our security engineering baseline. We know what that is because we've tested and done that STIG stuff in week 1 and further, right? So we've been building security engineering baselines this whole time. I didn't just throw that word out there if you've done the course and go, "Oh, now there's a new term and now you need to know how to do it." No, we did this the whole time. And we released a server. We built a device, some server. And then we built a build and a runtime book as the server was built. So how it was built through its CI/CD pipeline or whatever, however Ansible playbooks and other things that were involved, that's its build book. If I needed to push a button and rebuild this server back to that baseline, that would be the build book, right? I can go push a button if I have the permissions. The run book or the runtime book, run books, those books are how we keep the system operational. And we sometimes, as we first build out a system, we build the run books or like the operational books as we go. And that's some big book in the movies where like you're like, "Oh, how do I fly? How do I land this plane?" And you're like, "Oh, this is a bad way to. I'm already in the sky and I'm trying to learn how to like land a plane." That's a bad time, but it's better to have a run book to try to land a plane than not, right? So build books and runtime, and then as soon as we push those servers out into the world, they start changing. Operations admin teams make changes to fix things. People put in tickets. User requests, tickets come in. There's security fixes. There's patches. Patches start coming right away. And configuration management must be followed. And then we update the runtime books and push that back into the original build, which we have procedures up on this or up on Killer Coda where I show you how to update a golden image. Because the worst thing you can do, right? Oh, by the way, function applied to rebuild the system, allows for operation of the system. Real quick, one of the worst things you can do is get 2 years into a server, right? Nowadays, we kind of think of servers as ephemeral, and this is kind of coming from Kubernetes and containers and stuff, but servers are still sometimes big, fat, stateful things sitting there. You get 2 years in and you've got to rebuild a server. Well, if you rebuild from the original build book and you've never updated it with all the runtime stuff, you're going to be on version 1.0 of a server, if you will, whereas you were just on version 1.27 of a server with 27 incremental changes, and that's a nightmare because now you got to rerun all those incremental changes. You're probably going to break things. You're not going to be able to get patches, and what's better is to go fix the original build, so now when you build it, it builds out as 1.27 in the more modern terminology. Now, I realize that the way we do containers is we just move it forward and then we never worry about going to the old one again. And that's maybe a better way, but I'm still telling you, servers still exist, guys. Hundreds of millions of servers out in the world. Conservatively, there's hundreds of millions of servers. Maybe even more, right? You say, really? Does everybody have that many servers? I have 80 myself, and I maintain about, close to 100,000, right, in different systems. So that's just me, well, me and engineers I work with. Yeah, there's a lot of servers out there, guys, right? So anyway, so we don't want to reintroduce stuff. Here's our server deployment process. Somebody requests a server with an API call. VMware has a manual kickoff. Maybe you run Terraform or an Ansible playbook, whatever it is. That playbook can be kicked off from Tower or Ansible automation platform, and the server build starts. Maybe a container stood up. Maybe a golden image is cloned from a VMDK to a new server. It's maybe a physical machine is allocated. Like you can have a physical machine in a data center that's not doing anything and it gets turned on. That could be, in some huge companies, that could be a real thing, right? Then there's things that are pre-baked in, and there are artifacts that are tracked in the CMDB, and these are universal, like LDAP configurations. When you're in a dev environment, you go to this LDAP, right? This Active Directory. All the STIGs, those are all pre-baked into the system. But then there's personalization, or what we call user space out in the cloud, customization that's built in as it's called. So is it a web server? Is it a database? Is it an app server? This is going to affect the other parts of the build. Up here might be tools like New Relic and other things that are always there. But down here might be personalization of New Relic to a very specific set of logging or whatever tracking for your application. But these things are on a server by server, environment by environment basis down here. These are pre-baked in, so they don't cost any time as the server stands up. These ones take extra time, so now you've got a trade-off there. The pre-baked versus user space type argument, and there's a whole bunch of cloud blogs, and I think I even mentioned some of them in the class when we were going through it, right? And then down here, I don't know why I didn't fix that yet, but typically, not typically, final checkout occurs. It is typically, but I just spelled it wrong. Final checkout occurs before handing it over to the users. Okay. Come down here a little bit more, aligning this back with the industry, explaining the importance of change management. Guys, I'm telling you, we both hate it and love it as engineers. And what I tell my junior engineers, and sometimes I have this little drawing I do. I know the drawing's stupid, but I'm still going to draw it for you guys. And I draw this, right? It's the worst wave you've ever seen coming out of the ocean. And you can either be up here, like this, on top of that wave, or you can be down here in the wave. Now, if I told you this is, okay, this is a wave, right, in the ocean, and there's this guy here, and there's this guy here, who do you think's having more fun? The guy on top riding the wave, or the guy who's tumbling underneath it, probably drowning right now, right? So, again, I know that's kind of silly, but it's true. I know processes outside of my normal engineering stuff just enough that I can be this guy on top of the wave. I've been showing my wife a set of movies. I'm not going to talk about that right now. There's these Escape from New York and Escape from LA movies. And at the end of the movie Escape from LA, he rides out on like an 80-foot wave. I told my wife it's the most ridiculous ending to a movie any person's ever seen. And she's like, oh, well, I want to watch it. So we just watched Escape from New York last night. And I'm going to make her watch Escape from LA tonight, or maybe this weekend. Well, she's baking cookies because her sister's, it's a long story. Anyways, we're doing a birthday party over here for her sister that's turning 40. And she wanted 40 different types of cookies. So my wife's been making cookies. People are bringing cookies. All right. Anyways, configuration or change management, approval process, ownership, stakeholders, impact analysis. All these things need to be tracked and monitored in a system, right? Technical implementations. What are allow and denies? What are restricted activities? Do we have downtime windows for different environments? Are we restarting a service or an application, and what are the implications of that? Can we roll through so that there's never a customer-facing outage? You have a lot easier time getting downtime in a system if the customer's never going to see downtime. It's true. It's very true. Oh, gosh, the Escape from New York is great, but Escape from L.A., I didn't hear a single reference. So Snake Plissken is Kurt Russell's character. Nobody asked him, oh, I thought you'd be taller. And I told the wife, I was like, I just swear they told him that in all the movies, but apparently that's only an Escape from L.A. So I can't wait for her to see it because it's always, yeah. Well, Hello Mateys, they have, she's got like 5 or 6 other people bringing cookies as well, and some of them are also like pre-baked, like Oreos and other stuff. And it's not all for the sister, right? The sister's actually pretty fit. It's for all the friends and family and nieces and nephews and stuff. It's not just for. She's not going to sit there and put a bib on and eat 40 different type of cookies in front of us. Oh my God. That would be terrible. But yeah, it's like a big thing. So, and then it's funny. The wife was having people try cookies today because I had some friends over earlier, and they were eating coconut cookies, and I just don't do coconut, right? So, all right. Anyway, so more aligning with the industry, the purpose, the types of audits you might run into. You've got internal, external, and pen testing type audits. Internal. Well, before internal audits, even there's this self-attestation. I'm going to tell you I did these things, and I'm going to build these STIG reports and stuff like that, and we're going to put stuff into Archer and these different tools. That Archer's a very common risk management tool that companies use. I'm going to attest that I've done these things, and then somebody else is going to come along and check me. Probably my security blue team. They're going to check me for compliance. They're maybe going to have an audit committee. Maybe I'm doing self-assessments and sending information up, or we're doing like somebody's over my shoulder watching in a meeting or something like that. Yeah, absolutely. Hello, mateys. I enjoy doing this. This keeps me sharp. So then external, right? If you ever do PCI compliance, right, payment card industry, you will do an attestation and do your own internal audits. And every 6 months, external third-party auditors will come in and they will check you. And then they will give you typically 6 months to remediate anything they find. And then if you are found to be in compliance at the end of that, they go, okay, that's good. Get ready for another 6 months from now. Make sure you're still good. And that's third-party auditors. Like, I'll tell you what, if you always want work, go be a PCI auditor. Like, I know there's a certification for it, but go do PCI third-party audits. You'll always have work. because anybody that wants to deal with payment cards and taking credit cards has to be part of PCI. And so they'll need people to do it. Penetration testing. This can be external, like a third party, or we used to run our own red team at AAA. I told you guys I used to be the red team tech lead. And we can do physical pen testing. People try to get in. They try to walk in. They try to come in behind people, like start talking with a group and try to walk in. They try to like open doors and get close to the facility and just do stuff like that. And sometimes those people are hired or they're third party, but typically they're hired and they have very specific things in place. And this has made it in the news a few times since COVID hit. People going and trying to do stuff on government sites and getting arrested. But then it's like, no, we're part of a pen test team, and then they get let go and stuff. There's offensive, there's defensive. Penetration testing tends to also be, there's integrated, there's all kinds of stuff. There's also just OSINT gathering on the network. If you want to get into this, there's a lot of ways to do it, but the place that I would tell you to start is go to attack.miter.org. I'm always showing you guys that. Attack.miter.org shows you the attack kill chain. It's been around since the 70s, shows you how to connect to stuff. There's known environments, partially known environments, and unknown environments. We tend to call this white boxing, gray boxing, and black boxing for your types of scans. And then there's reconnaissance, passive and active. Passive is just checking things like you're doing normal user stuff, looking for expired certificates, looking for headers on web pages, checking all the domains and subdomains that exist, walking, looking for robots.txt. There's like all these things, right? And people go and get certifications in this, and there's value out in the industry, and people want pen testers, and everybody wants to be that 1% of the red teamers, right? Like fun, sure. But there's passive where you're just doing stuff, not even actively, you're just on the system, on the internet, tracking things. And then there's active where you're actually pushing on things and that kind of stuff. Hey, Rob, how's it going? I am recording my Unit 10 security engineering course. So, hey, Raiders, you're welcome to hang out. I'm about at the end of it, but this is a 10-week course that we ran on securing Linux. And we're getting down to Unit 9 now. So I'll finish up Unit 9, and then I'll do a quick run-through for everybody. Actually, I'll do a quick run-through up to 9 for you guys, just because people came in. This is a course that ran for 10 weeks. Actually, it went a little longer. And the goal of it was to understand securing Linux in an enterprise, right? And what happened was we had our last week and stuff. These were the areas we did. We did building the server, getting the server up in a secure fashion. Then we added it to a network. We allowed users in. Then we moved the system off into a secure bastion, and we built a bastion and air gaps and all those kind of things. Then we understood patching and patch cycles of the organization and having internal repos. Then we did monitoring of logs and monitoring and alerting and all of these type of things. Then we were just done with configuration drift and remediation, so how we keep users from doing things and changing things on systems, and how we do that as secure as possible, right? And then we did certificate. We're about to get certificate in key madness. So all this stuff, this is all recorded up on YouTube. So if anybody wants it, you can go through. And again, we were only touching each of these pieces. We weren't going heavy into them like we did in the actual courses. For each of these, we talked about what it was, certificate in key madness. We did some theory, things we needed to know. And then we did some practical application, some things we needed to do, right? So in theory, what is identity and how is it established? Well, we can identify a person or a process or an application by we can identify it cryptographically. We can identify it via keys and tokens that it might have and all these kind of things. But identity is something I can trust to be a thing, and then I can give access to, right? That's what a identity is. Then we talked about encryption and how does it protect data? Well, we have the idea of plain text over here, pass something through a cipher. Now it's actually protected in a tunnel. It's actually kind of like a tunnel until it gets to the other side and it gets decrypted and it pops out on the other side. And the way I kind of think about that is, have you guys ever seen like I know My Hero Academia had it, but there's I think Into the Spider-Verse, which I never saw, but had this character that could like punch into space, and then he would go into another dimension, then he'd pop out over here and he'd hit you in the side of the head. And you're like, the hell, you're like 30 feet away from me, but you just punched like that into a little place, and then you came out over there. And that's kind of what, like in my mind, a cryptographic tunnel is almost like you're sending the plain text data somewhere else, and it's useless to anybody until it gets deciphered back to the original data, or encrypted on one side, decrypted on the other side, right? So we talk about encryption. How does it protect data? Well, it changes the data, but it can also be used for hashing data as data are moving through a network. So we're moving packets along a network with TLS, and we're doing hashing on each packet. And on the far side, we're making sure with the hash that that packet didn't change in any way before it comes back to a data stream and then gets decrypted, right? So we can verify that two ways. In two ways, we can both protect the data confidentiality, nobody can read it, and also protect the data integrity because nobody can change it because the hash is always going to be correct. So how can encryption prove identity? Well, if you have a thing, or you are a thing, or you know a thing, or you are somewhere, those are factors of authentication. So encryption can prove your identity because nobody knows what Rob knows for his password, or nobody knows what Zorgel, who was around earlier, could possibly know, right? This happens. That does happen very quickly. Hello, mateys. In fact, we talk a little bit about that. But what are authentication, authorization, and auditing? The triple A's. This is a very common thing. The further we move away from sitting at a machine, like this was happening before COVID and before people started working remote. It might be surprising to you, some of you that don't know, we used to have to go in the data center to do all this stuff to our boxes, our servers. But we wanted to get further and further away. We wanted to sit at our comfortable desk in the office and not be in the data center all the time. Guys, data centers are loud, and depending on which side of the rack they're on, they're typically very cold or very hot. Depending on which side of the rack you have to sit on to work on whatever the thing is that day. So we want to be further and further away from the system. So we want to be able to authenticate and get into the system remotely. So authentication takes one of those factors to prove that you are who you are. And then we can authorize you from that proof, right? You can say you're Rob, and then Rob can then have permissions to be, engineer, leader, or whatever on the system. He's got root access. He can do whatever he wants. But then we still track. Because typically in most modern systems, you have to come in as your user and assume you have to put on the little helmet, or you got to put on the little star and be the sheriff before you get root privileges. Well, we can track all of that. We can audit everything. The user did what? Like that's the question always, right? And then how does trust work with authentication? Well, if I wanted to trust, and I know Rob probably had to bounce, but if I wanted to trust that Rob was who he said he was, I would have to maybe have been in his channel before, and then I trust Twitch to know who Rob was. And then now I've been introduced to Rob through Twitch. So then if I meet Rob out in the world someday, I'll be able to know it was Rob because Twitch introduced us. And that's what trust is. I trust some third-party certificate authority. Your browsers automatically trust some out of the gate, but you can set other ones to be trusted. And I can download public certs from them, send information in an encrypted fashion to only the person who should have the private version of that key that I get for that server, and they would be able to decrypt it, and then we'd be able to talk over TLS, and I would know that they were who they say they were because I was pointed to them and trusted the certificate authority to introduce us, right? So that's trust, right? Trust is very important. And then we talk about data in motion, transport layer security, TLS operations. We'll get into that a little bit, or that's what we did that week. I think we review it a little bit here. Practical applications, we use TLS for syslog messages. In the lab a few before, we just sent messages with UDP, and it was like, oh, this is sad. We're sending UDP logs, cool. Anybody could connect, anybody could talk, but now only the people who are supposed to be talking over TLS will be doing it, and the messages are encrypted in transit, so that's good. Then we generated and verified public and private key pairs, made sure that we could connect to different systems. That was part of the labs. And then, and then we did public and private key pairs via just SSH, not just regular key pairs that we were generating. All right. Aligning Unit 9 back with the industry. We have things called public key infrastructure. We can have them internal to our organization. Then we have a public key and maybe a private key, and then key escrow is a third party that will keep keys for us. In case anything ever goes down or is unavailable or we need to pull it back, we can have a key escrow. And public key infrastructure can be run by us or some third party that we trust. And then encryption, we're not right now talking specifically about encryption, but it's very important to understand symmetric encryption. When we did that cipher earlier and took something from plain text to ciphertext, that symmetric cipher or symmetric encryption uses the same key on one side as it does on the other. So if you use like A equals 1, B equals 2, C equals 3, and then you make some cipher that's completely uncrackable, on the other side, that same decryption happens where A equals 1 or 1 equals A, B equals 2, right? And it goes backwards to make it back into, completely unbreakable, right? And there's all kinds of shifts. Maybe you go over and then you shift down 5. That's a common one, right? Like in simple speak. That's symmetric though. In symmetric, the same key is used on both sides. Asymmetric is different. They are what we call cryptographically related keys, but they are one-way keys, one-way algorithms where if you go through the from the private key, you can generate public keys as needed. And then if you ever pass traffic in from the public key, right, you generate and encrypt traffic, you can no longer come back out. In fact, do I have it here? No, I don't have it here. I have it in the actual course when we did Unit 9. When it goes in, it can only come out from the private key. Only he can pull it out of that other dimension or whatever, however you think about it, right? However, you can't pull it back with the same one. So if you encrypt something, you can't decrypt it with that public key ever again. Only the private key can decrypt it now. So that's very important. So that's asymmetric keying. Asymmetric keying takes 10 times the cost for the same work as a symmetric key. And that's very important for you guys to understand because asymmetric keying is how we establish trust, like PKI and infrastructure, and then we establish a symmetric key to talk between them so that we're using way less of the actual processing power. We call that communication, when we go from asymmetric down to that, TLS termination, and that tends to be done at load balancers and web application firewalls nowadays to offload some of the processing of our application boxes that are further on. That's outside the scope of this course, but that's something to kind of understand and dig into if that's something that's interesting to you. Again, I said early on, get your notepads out if you want to, I'm going fast, right? There's a key exchange where we establish that you are who you say you are by sending over from a public key that we can download from the certificate authority, that we send over some encrypted string. Only you can decrypt it and send it back to us. And we go, yeah, you've got to be the person I trust because I've been introduced to you, right? There's tools and all kinds of different things. Trusted platform modules are typically built into motherboards, and you can do all kinds of encryption with them. Hardware security modules are key management systems up in the cloud, and also you can have them locally. There's always in HSMs and key management systems, there's always a separation duty between the key creator and the key user. So there's like the key creator, key custodian, and then the key user or data user, whatever it is, right? And then secure enclaves are where you keep them so people can't mess with them. Obfuscation, steganography is anytime you store something in picture form so people can't see it. Tokenization is when we change something via a token that can then not be traced back to the original data. And data masking is where we just block off certain parts. So if I was going to show you guys my social security number, let's say I was going to do that, and you guys all knew that Scott had a social security number that ended in 2863. Let's say that was the end of my social. I might mask off the first, it's 9 bits. So the first the first 5, I would mask as X's. Masks mean nothing. There's no way to demystify a mask or send it back. It's just literally just X's instead of the values. Tokenization, the values mean something, but they don't mean anything to you because of the shift. They're never going to be decrypted by you unless you understood how the tokenization occurred. And that's kind of an important thing. Tokenization, the original data, is still there if you need it. You just have to have the right tool to decrypt it, right? Then we have hashing and salting and all kinds of other things that are, good to go read about and get into. Again, this is all aligning back with the industry, things we necessarily didn't get time to talk about, but were very useful and I think valuable to know more about. All right. And then there's our review. We built our servers. We secured our network connection. We allowed users in. We did a bastion air gap to allow people into a separate network and separate system. We updated our systems and did patching and those kind of things. We monitored with just logs and monitored with alerts. We did configuration drift and remediation to keep our systems all in line the way they needed to be. And then we looked at how we secure communications into our systems, right? So that was the major part of it. Now, Things I didn't get to that I think are valuable, and maybe future versions of this course will add a few days, is for sure resilience and recovery. High availability, load balancing, being able to fail over and having a virtual IP that either node will respond to, whether it's the active or the passive, right? The site considerations of hot, cold, and warm, and what the costs are, and how geographically dispersed something should be. You should have your data centers, if you're going to have highly available data centers, they should be more than 500 kilometers apart, maybe. And different vendors are going to do different things. Platform diversity, you don't want to be vendor locked in or vendor locked out from a cloud. So platform diversity is, if you're using a service inside of like AWS, how easy would it be to move out and move into a different cloud provider if you needed to, right? Being in multi-cloud hybrid systems, are you using private clouds, your own? Are you using public clouds that anybody can use? Are you using hybrid clouds or different types of clouds that exist out there, right? Continuity of operations, do we want to be returned to operations quickly, or recovery point objective close to where the incident occurred? Those are two things to consider. Talked a little bit about them earlier. Capacity planning, watching before we hit that red line and we can no longer get more customers or more things in. People, technology, infrastructure are all valuable for that. I'll tell you guys something. The other day I was talking to somebody who's planning out next generation for some of our government NOAA stuff, and he was looking at taking different types of data centers, and me and him were talking extensively about Kubernetes because he's been in the industry 30 years. I've been in the industry like 25 almost. And anyways, we were talking, but he's heavily set on just high performance compute stuff. And he was talking about, having Kubernetes in these systems and these kind of things. And we were talking about it. And I was telling him, one of the things I was telling him is, and I said it twice, and then he goes, that's the second time you said that. That's actually really interesting. I hadn't thought about that. But we were talking about people. And what I was saying is one of the nice things about you doing Kubernetes in this newer data center you're planning across 3 data centers, in fact, instead of just 2, if you care, was I said the people, there's a lot of people that understand Kubernetes. It's the way the industry's been going. There's a lot of people trained up in Kubernetes. You're not going to have a hard time getting people that understand this technology for your system. And he goes, yeah, I didn't even think about that. But yeah, it's like true. If you go put out there that you need like Gluster and some very specific version of GPFS, you're not going to get a lot of people. You may get a lot of people to respond that are Linux people, but you're probably not going to have a lot of people that actually can do that work. So capacity planning is also around people that can do the work, right? And with Kubernetes, it's very popular. So you could get a lot of people from around the industry to come in and possibly work on your projects, right? Testing, how do we walk through things? How do we fail over, or how do we simulate failovers? And then what can we do parallel processing where we're sitting in 2 different environments working off of maybe the same database? Is that possible? Are there latency considerations? When we flip a database, there's always latency considerations when we're talking about online transaction processing in a database, right? And then backups. This one everybody hates tape, right? But how often do we send tape offsite? Are we backing data up to tape so that we have that ability to pull data back later, right? What's the frequency? Are we putting encryption on it? Always. Are we doing snapshots, and how big are the snapshots getting? What's our recovery time? If you're putting data off to tape for 30 years and you're never thinking about the time it takes to bring that tape back, you were trickling data out, but now you need that data back, but you only have like 2 tape. I don't know if you guys have ever seen a tape arm move, but if you ever need to see one, watch the movie Eraser. There's a movie Eraser from the 90s with Arnold where he's like kills people and there's these rail guns. And but at the beginning, there's like a big tape arm moving, and some people have never seen a tape array, and it's kind of cool if you've never seen one. Journaling is a file system concept. You need to know this. ext3, ext4, and XFS all journal. ext1 and 2 do not, so you don't use them anymore. But journaling is the idea that we don't change the original file. We actually change a copy of the file, and when we're ready, we just flip the inode pointer over to the new file. So if anything were to happen during that write or change of that file, you're not affecting the original file. That's what file system journaling is. Very important to get rid of things like system crashes because you were working on a system file, right? And the system powered down. Generators, right? Typically diesel generators, you have to have 48 hours worth of uptime. And your UPSs need to keep your system up until you can flip over to the generators, right? And then sometimes help you flip back. I've been in a data center before, guys, where we flipped over to diesel power. We had a problem. It was out in Goodyear, Arizona. and the power was not good. And the power went down, but our diesel generators caught it and our UPSs caught it, and we were good. But then the flywheel got stuck and we couldn't go back. So we had to power the data center down to move back to real power. So we didn't take downtime in an unexpected fashion. We caught it. And then we were running on that for a few days. And when we were ready to go back, we couldn't do it. So then we had to plan downtime to turn the whole system off to go back. And I always thought that was kind of funny. It caught it, but it caught it like in a way, like have you ever caught plates? Like you drop a bunch of plates and you catch them, but you know when you move, you're going to lose one or two of them. I don't know if any of you ever worked in the service industry, but when you're younger, maybe you caught some plates and you're like, I got them. But when I move, I'm going to lose that freaking fork or whatever. Well, forks aren't that big of a deal, but I'm saying, you're going to lose a plate or something. So that's something. All right. Other ones that we didn't get into. We did a lot of baselines and hardening of systems, but we didn't do mobile and we didn't do wireless. So we didn't talk about any of this because this doesn't really happen in the server room. But I wanted to give it a nod because these are effective things to know about. We don't just harden the Linux box. We also harden the application. We can harden Internet of Things devices, and their communications can be TLS instead of UDP, which is always smart. Can't be tracked or can't be read in transit. You can only read it at one end or the other, right? Routers and switches have secure benchmarks from SCAP or STIGs, so we have STIGs for those. Workstations should probably be STIGed as well. And we were really only worried about servers in this. But our interaction with the cloud should always be over TLS, right? We should always be securely doing that traffic as well. And we need to be protecting our keys because our keys shouldn't be showing up in different versions of Git and getting popped and that kind of stuff. So there's mobile stuff, there's wireless stuff. We didn't touch any of that because it wasn't really big in the server room. But in securing Linux, we do need to understand these things for sure. All right. Other things that we didn't get around to. Use cases for automation scripting. We're going to do a whole automation course, so we're going to touch all of this stuff. We're going to hit, understanding how to hit an API is maybe one of the most valuable things I ever learned. As a systems engineer, I didn't need it the whole beginning of my career. But now, as we are so much, even if you still want to just be a systems engineer and platform engineer and just play with Linux all day, the fact that I can hit APIs and pull data out has made my life so much easier for maintaining servers and keeping inventories up to date and all these other types of things that I might almost call this one of the most important skills to have that isn't directly Linux related. Being able to use like Ansible or some other tool to hit an API in a pipeline is huge. So huge. In fact, I'd be willing to bet if you made a little poll down in our Discord and said, engineers that have been doing this for more than 10 years, do you know API stuff? I'd be willing to bet you all of them put yes. But or do you do APIs every day? And I bet you almost all of them would put yes as well, even if they're not directly like a software engineer. They're just some other type of engineer. It's just so useful. I can talk, and some companies try to get to what's called API first interactions. So I don't have to call you over in security and ask about something. I can just hit your API. I might have to call you the first time and you guys tell me where the API is, but then I can always just pull the API, see how fresh the data is on it, and I never have to bug you again. Only if the API is down, right? And so that gives you a reason to keep the API up, right? And updated, because now the data is always going to be good. Benefits and other considerations. There's so much, like keeping the human error out of it. If you guys have ever watched me type, you probably watch me type 30 errors per minute, right? I type a tremendous amount of errors. I make no errors in my automation playbooks. Oh, don't get me wrong. I make all kinds of errors when I first build them. But by the time they're ready for prod, they are they're like an F1 car going out on the racetrack. And if you were ever to watch me build them, you'd be like, this guy's never going to fucking have a working anything. This guy's a madman. But then when it goes out and it rolls out on that track and goes into production, it's always good because, you can fail all you want in the dark, right? But then you got to have your processes good to make stuff look good. So I never make any errors in production, and that's a big part of being a good engineer. Don't make errors that face the customer. Make all the errors you want in your little training area. Don't make it out there like in the live area, right? All right. Other things, incident response. I have other talks on incident response. We did not do any of it here. We do it in the other Linux admin course, though. But in the security course, we didn't touch any incidents directly. Third-party risk assessment. I talked about it, but I didn't make you guys really look at that too much. And then effective security compliance. We talked about this, but we didn't talk about non-compliance and those kind of things. So that would be something that may slide into the course. We'll probably take this from a 10-week course in the future, maybe up to like 12 or something, then we'll re-record them as we go. And then, security awareness and implementing security awareness. It's funny. This is what my dissertation's on. So we didn't even touch it, but this is what my dissertation's on. But this is kind of outside of being like a Linux admin and Linux engineer, security stuff. This is about retraining your users. I always talk about there's two things that can be misconfigured in your system, your systems and your users. This is about fixing the users. Fix their knowledge, change their attitudes, or fix their knowledge, update their attitudes, and fix their behaviors, right? It's KAB model. And that's a thing that we would kind of work on there. And then that's it. All right, so if you got questions, let me know. I'm going to go ahead and stop this here. This was our Unit 10 of the Professional Linux Users Group Security Engineering course. Hopefully you guys like this stuff. I will be back on tomorrow and we'll be working on more stuff. But I really wanted to get this recorded for you guys so that people can review it and that kind of stuff. So thank you guys for coming. I will see some of you later.